In this video, we are going to solve the examples on exercise 4.1. So let's see first example. Find the condition that the line 3x plus y is equal to 0 may be perpendicular to one of the lines given by homogeneous equation of degree 2. This is the find the condition that problem. Here we use the auxiliary equation of homogeneous equation of degree 2. So first consider the auxiliary equation of ax square plus 2hxy plus by square is equal to 0 is bm square plus 2hm plus a is equal to 0. Now the given that one of the line is perpendicular to 3x plus y is equal to 0. So since one of the line is perpendicular to the line 3x plus y is equal to 0, whose slope is minus a upon b, that is minus 3 upon 1, coefficient of x upon coefficient of y, that is minus 3. So the slope of this line is minus 3 and slope of perpendicular line is negative reciprocal of this line, that is minus 1 upon minus 3, that is 1 upon 3. Now the slope of this perpendicular line, that is the slope of one of the lines given by the homogeneous equation of degree 2. So m is equal to 1 upon 3 is the root of this slope is the root of auxiliary equation bm square plus 2hm plus a is equal to 0. So here we use m is equal to 1 upon 3 is the root of the auxiliary equation bm square plus 2hm plus a is equal to 0. So substituting m is equal to 1 by 3 in this equation, we get the required condition. So b m square, that is b into m is equal to 1 upon 3 bracket square plus 2h into m is equal to 1 upon 3 plus a is equal to 0. By solving this, we get the required condition. So 1 upon 3 square is 1 upon 9b plus 2 by 3 h plus a is equal to 0. In this equation, 9, take the 9 as LCM, then we get b plus 3 into 3 9, so 2 into 3 6h plus 9a is equal to 0, and in proper form 9a plus 6h plus b is equal to 0 is the required condition. So for this example, we use the auxiliary equation of homogeneous equation of degree 2. Now let's see the second example. Find the joint equation. Find the joint equation of pair of lines passing through the origin and making an equilateral triangle with the line y is equal to 3. Here we have to find the joint equation of pair of lines passing through the origin, and this line making an angle, making an equilateral triangle with the line y is equal to 3. So first let us draw the figure of this example. So in xy coordinate system, first we draw the line y is equal to 3, which is parallel to x-axis. Y is equal to 3. This is y-axis, this is x-axis. Origin O. And the lines passing through the origin, which makes an equilateral triangle with line y is equal to 3. So this, the line passing through the origin, denoted by OA and OB. Now the line OA and OB passing through the origin and makes an equilateral triangle with this line y is equal to 3. This is equilateral triangle, so these lines makes an angle 60 degree with the line y is equal to 3. So each angle of this equilateral triangle, this is the equilateral triangle. Each angle of this equilateral triangle is 60 degree. And so write the explanation. Let OA and OB be the lines passing through the origin making an angle of 60 degree with the line y is equal to 3. Therefore, OA makes an angle 60 degree with positive direction of x-axis. The line OA makes an angle 60 degree with positive direction of x-axis, and the line OB, this line OB, make an angle 120 degree x-axis. So we can write the line OA and OB makes an angle 60 degree and 120 degree with positive direction of x-axis. And we know that the angle made by line with positive direction of x-axis is the inclination of that line. So the inclination of line OA is 60 degree and inclination of line OB is equal to 120 degree. And using this inclination we get the slope of lines, and using the slope we get the equation of line. So first write the inclination. Theta 1 is equal to the inclination of OA is equal to 60 degree, and therefore slope of OA is equal to tan 60 degree. We know the formula of the slope of line, tan theta. So using this formula we get the slope of line OA, that is tan 60 degree, and we know that the tan 60 is √3. So the equation of line OA is equal to, OA is, using the formula y is equal to m1x. m1 is the slope of line OA. So using this formula we get y is equal to root 3x, that is root 3x minus y is equal to 0. This is the equation of first line OA. Now using the inclination of line OB, that is theta 2 is the inclination of OB is equal to 120 degree. So slope of OB is equal to tan 120 degree. This can be convert into allied angle, that is tan 180 minus 60 degree. 120 means 180 minus 60, and 180 minus 60, this angle lies in second quadrant, and in second quadrant tangent function will be negative. So the value of tan 180 minus 60 is minus tan 60 and minus root 3. Value of tan 60 is minus root 3. This is the slope of line OB. Of line OB is y is equal to mx form minus root 3x, that is root 3x plus y is equal to 0, and this is the second equation. Now here we have to find the joint equation of lines. So using these two equations, we get the required joint equation. So the joint equation of these two lines is the product of these two lines. So joint equation of lines is, first equation is root 3 x minus y into second equation root 3x plus y is equal to 0. U into v is equal to 0. Now in this equation, the first bracket is a minus b and second bracket is a plus b form. So using the formula a square minus b square is equal to a minus b and a plus b. So we can write the expansion of these two brackets is first term square minus second term square is equal to 0. So by solving this, 3x square minus y square is equal to 0. This is the required joint equation of given lines OA and OB. Now let's see the third example. If the slope of one of the lines given by ax square plus 2hxy plus by square is equal to 0 is 4 times the other, show that 16h square is equal to 25 ab. In this example, the slope of one line is 4 times the other. So first let's consider the slope of lines represented by homogeneous equation. So let m1 and m2 be the slope of lines represented by the homogeneous equation ax square plus 2hxy plus by square is equal to 0. And we know that the sum of slopes of lines m1 plus m2 is equal to minus 2h upon b, and product is m1 m2 is equal to a upon b. And also the given condition is the slope of one line is 4 times the other. So we can consider m2 is equal to 4 times the slope of first line. So m2 is equal to 4 times m1. Now we can substitute the value of m2 is equal to 4 m1 in the sum of slopes. So m1 plus value of m2 is 4 times m1 is equal to minus 2h upon b. So the m1 plus 4 m1 is equal to 5 m1 is equal to minus 2h upon b. So the value of m1 is equal to minus 2h upon 5b. Say equation 1. Now the product of slope m1 m2 is equal to ab. m1 m2 is equal to a upon b. So the value of m2 is equal to 4 m1. Substituting this value, we get 4 into m1 square. m1 into 4 into m1 is equal to 4 m1 square is equal to a upon b. Now we have the value of m1 is equal to minus 2h upon 5b from equation 1. So we can substitute this value in this equation. Then we get 4 into minus 2h upon 5b bracket square is equal to a upon b using the equation 1. Now simplifying this equation, we get 4 into minus 2h square, that is 4h square, and 5b square is equal to 25b square is equal to a upon b. 4 into 4 16h square upon 25b square is equal to a upon b, as b is not equal to 0. So here by cross multiplying 16bh square is equal to 25ab square. Here b and b square, 1b will be cancelled, then we get 16h square is equal to 25ab, and this is the required expression. 16